Hey everyone, and welcome back to the channel. So today I'll be giving you an introduction to the new PhysX Fluid Operator inside of tyFlow, which allows for two-way interaction between tyFlow and PhysX. In other words, you can have objects float in water, you can have objects be pushed by a liquid or even destroyed. So this was another example that I made of just some simple wall destruction, and the pieces are being pushed by the water and they interact with it. And then I made another example where the boat is destroying this wooden dock and you get some of that wood floating in the water as well. So there's a lot we can do with this new operator. I'm just scratching the surface. I'm sure very soon there's gonna be some much bigger destruction scenes, some cars floating in water and stuff like that. But just to get us started, we're gonna do this sort of Instagram satisfying style effect of basically 2,500 spheres floating in the liquid. So I'm in max and I'm working in units, centimeters. 1 unit is 1 centimeter. If you want your results to look the same they did for me, make sure that you're working in the same units. And we can create a PhysX liquid grid, and then let's just make a liquid source. And I'm just using these shortcuts down here, but you can also go under helpers, PhysX and create a liquid source from here. And then we also need to create a standard tyFlow. And before you forget, go under interfaces and enable the particle interface for tyFlow. And then right click on tyFlow, go to PhysX properties and make it a solid object. So these two things you need to do in order for the liquid to interact with tyFlow. Then we need some kind of a source for the liquid. So let's just make a box on the side here and make it an editable poly. Select this polygon, make it maybe ID 10, and go into the source, add the box as our source and set the polygon ID to 10. So again, that's just so that the liquid will only be coming out of this polygon. Now we just need to give birth to some particles, helpers, tyFlow, and create a ty icon. And I'll just make it the same size as my PhysX grid, so about this. Let's do a standard birth and set it to maybe 500 particles to start, and we want them to get born on just that one frame. And I want them to be born on this icon, so let's just do a position icon, pick the ty icon here. And now we need to give them a shape, so let's just add a shape operator, set it to 3D, sphere low res, and set display to geometry. And then you can go back into shape and set the scale to maybe 500 and make sure that it's sitting above the ground, so we can just raise this up a little bit. And we need to make them PhysX shapes, so let's just add a PhysX shape operator here. So now they will immediately fall down under the force of gravity. Now what will happen is the spheres will be pushed by the liquid. But remember that tyFlow is not aware of where the PhysX grid ends. So they will not automatically bounce off the walls. The liquid will bounce off the walls, but the spheres will just fly out. So we need to create a few collision boxes as sort of walls for the spheres to bounce off of. So I'll just make one of these, go to object properties, make it not renderable and display as box. And you can just hold shift, drag, hold shift, drag, and put this over here. So I just created a few walls around the grid. So just add a PhysX collision operator here, and you can do pick and hit H on your keyboard and just select those boxes 2 through 5 that we just created as our collision walls. And before we forget, you can also add a mesh operator to make sure we'll be able to render this, and make sure you uncheck render only. So this will allow PhysX to see the spheres as actual geometry inside of the viewport. And while we're here, before we run the liquid simulation, let's just add the material. So you can do just material ID and set it to maybe a value of 5 and set this to random. And I've already made some multi-sub object blue material, so I'll just apply that to tyFlow. So now we can just go back into the PhysX settings here. Under grid, we want to say jam both on all axes. The cell size of 1 centimeter is fine. We're getting about 2 million total cells. That's fine. Under output, just make sure that you're outputting it into a folder somewhere. So just browse and save it where you want it. Make sure that you're outputting velocity. Under preview, we can say show mesh and disable the particles. And now let's just add the PhysX Fluid Operator here. So now you get just a few settings here. For the fluid node name, I will just copy the name of our Phoenix grid, Control C, and put it here, Control V. And then make sure that you click Auto Setup Phoenix FD Container. Click that, and it will automatically set up a few things to make sure that tyFlow will work with Phoenix properly. So it's going to output pressure and a few other things. So just click yes. And at this point, let's just leave these settings at default. We can just run the simulation. So I'm just going to use the toolbar here and say start simulation. All right, so I'm running the simulation and everything is working beautifully. This is super fun to play with. I would definitely encourage you to play around with this. It's super satisfying to watch. But basically, you only have a few settings here. Velocity controls how much speed the shapes are given based on the liquid. So it's set pretty low right now. For my example here, I did 0.5. So especially toward the end, you can see that we're getting some nice motion over here. So you can just increase the velocity. Buoyancy controls how much they float or sink. So in my example, again, I did 0.8. If you do buoyancy 1, they can look very, very light. So for something like wood, maybe I would do 0.7. You really just have to play around and see what looks good for your particular scene, but I'll just do 0.7 here. The fluid density I found has more of an overall effect. So if you just want the liquid to have a stronger effect on everything, you can just raise this to 2. The pressure I don't usually touch very much, but I found that it has an impact on the speed and the motion of the particles. So if you're getting some particles that are moving way too fast, sort of just changing direction rapidly and all that, you can lower the pressure. So maybe we can make that 0.7 as well. And the drag will just slow the shapes down over time. So I just left that at default. So I'm just gonna run the simulation one more time and stress one very important thing, which is that, Phoenix and tyFlow are dependent on each other. So after you run the simulation, if you change any of these settings in tyFlow, the whole thing will update and the spheres will not match with the liquid anymore. So after you're happy with everything, you run the simulation, you can just add an export. Let me stop this so it's faster. So you would just add an export node and export the particles before you change anything, because it's easy to just, move something and then the whole thing updates and they will no longer match. So it's just something that you have to be careful about. But if you just run the simulation, it will save the position of the spheres into cache, and then you can render everything and everything will look good. This is working beautifully. We're basically getting exactly the same result that I had here. The only thing that I changed to make it more interesting was that I just added more spheres. So you can just go back into birth and maybe raise it to 1,000, 2,000, whatever you want. You can, use cubes, you can use any kind of an object. Now for the lighting and rendering, it's pretty much the same as in all of my other tutorials. So I just have a standard V-Ray light here. I have some V-Ray materials applied to the sphere. And then I have this water material for the liquid, where it's white reflection, white refraction, black diffuse, 1.3 for IOR. And the fog color is this blue color with 0.1 fog multiplier, which will give you this sort of light blue transparent liquid. So I hope that you guys found this helpful. If you did, as always, I would appreciate a thumbs up. If you are new here, welcome. I'll be uploading more, so definitely subscribe and hit the bell so you don't miss out. There are a ton of tutorials for you to check out and learn from. Thanks so much for watching, and I'll see you in the next one.